it is found that when R is equal to 4 ohm, the current is 1 ampere. And when R is increased to 9 ohm, the current reduces to 0.5 ampere. They are asking find the values of EMF and the internal resistance. So what uh, is the question? The question is that we have a cell, of EMF E and internal resistance R, and first we have connected that cell with 4 ohm resistance, and we are getting a current of 1 ampere, and after that the same cells we are connecting with a 9 ohm external resistance, and we are getting a current of 0.5 ampere. So for the condition, first you will write, you have a cell here, resistance is 4 ohm initially, and this cell has EMF E and internal resistance R. And suppose this is the current flowing, and current is given as first 1 ampere. So can I write the equation of current here? We
Yes,
can write the equation of current. What is the current? Current is equal to I is equal to E divided by R plus small r. So what is I? I is 1, E is, we have to find, and R is 4, and this is R. Okay. So from here you can get E is equal to 4 plus R. This is equation number 1. Okay. Now we have connected a resistance of 9 ohm with the same cell. A resistance of 9 ohm is connected with the same cell, and this time the current is 0.5 ampere. So we can write current is equal to E divided by 9 plus R. And when you will solve this, you will get E is equal to 0.5 9 plus R. So E you will get 4.5. When you will multiply this 0.5 to 9, you will get 4.5 plus 0.5 R. This is your equation 2. And when you will compare equation 1 and 2, so see, you can see here this E is equal to this, and this E is equal to this, means this value is equal to this value. Okay. This value equal to this value. So now we can solve it. Here 4 minus 4.5. Here we will have 0.5 R minus R. Here you will get minus 0.5. Here you will get minus 0.5 R, and this cancel, and 0.5 and 0.5 get cancel out. You will get R is equal to 1 ohm. So internal resistance we have got 1 ohm. Now you can put this R in any of the equation. I am putting this in equation 1. What is the equation 1? E is equal to 4 plus R. E is equal to 4 plus R. So E I will get 4 plus 1 equal to 5 volts. So this is the answer for E. So this is the first question. So for the second question, See, this question we have already discussed, but this time data is changed. And one thing more I want to tell you now, the parallel combination of the cell or parallel combination of different cell is not the part of your syllabus, but I am just solving this question for just uh, because the parallel combination of cell is part of JE and NEET, so that is why I have taken this question.
Yes, sir. Yes, sir. Okay.
Yeah. So they are saying two cells of EMF, this 1.5 volt and 2.0 volt having internal resistance. This is not what, this will be ohm. This will be ohm. Okay. Mm, this is the misprint. So this is ohm. Here also, this is not watt. This is ohm. So we have E1 is equal to 1.5 volt and E2 2 volt. Means we have two cells and one cell having the EMF this and second cell having the EMF this, and the one cell having the internal resistance 0.2 ohm and second cell have the internal resistance 0.3 ohm. They are saying both the cells are connected in parallel and we have to calculate the equivalent EMF, and we also have to calculate the equivalent internal resistance. So we have done this question already. You can see here. This was the question. Here two different cells. Here two different cells are connected in parallel, and we got the internal. We got the equivalent internal resistance and the equivalent EMF as this. So we can use this formula. So for the parallel combination, equivalent EMF is E1R2 plus E2R1 divided by R1 plus R2. So you can find it. What is the value of E1? E1 is 1.5, 1.5, and R1 is 0.2. What is E2? E2 is 2. This is 0.3, and this is R1 plus R2. 0.2 plus 0.3. So this will become this thing. This thing will become 0.3. This will become 0.6. This will become 0.5, and you will get the answer 0.9 by 0.5 means you will get the answer 9 by 5 volts. This is your answer. And for the R equivalent, you can write 0.2 into 0.3 divided by 0.2 plus 0.3. So this will become 3 to the 6, 0.06 divided by 0.5. So increase here 1 0, you will 1 2 3. This will cancel this, and here you will get the answer 6 divided by 500, and you can cancel it out. This will become 3 divided by 250 ohm. So this is your R equivalent, and this is your E equivalent. So
Yes, sir.
just you have to apply simply the formula for the parallel combination. This is the equivalent EMF for the parallel combination. This is the equivalent internal resistance
Resistor.
for the parallel
Yes, sir.
combination. But this is not the part of your syllabus. So okay, you can skip this. So next question is very good question, I will say, and I am taking this question. Now see this question. This question was asked in 2016, and I will say this question is a good question. So for solving this question, the question is the plot means that this graph is given. the plot of variation of potential difference. Potential difference means V. V is the potential difference. Potential difference across a combination of three identical cells in series versus the current is shown below. Okay. What is
Yes,
the
sir.
EMF and the internal resistance of each cell? So EMF we have to find and internal resistance we have to find. And what is the condition? They are saying that cells are connecting like this. Means three identical cells are connected in series. These are the identical cells.
Yes, sir.
So suppose they are connecting in series with some external resistance R, and as the cells are identical, so EMF and the internal resistance of each cell will remain same. Okay, so
Yes, sir.
can you draw the equivalent circuit of it? Can you find the E equivalent? As this is
Yes,
the
sir.
series combination, this will become E plus
E1,
E plus E.
E.
You will add all the E's, then you
Yes,
will
sir.
get 3E.
Yes, sir.
Can you find R equivalent?
Yes, sir. R
R
plus R
plus,
plus R plus R.
it will become 3R.
3R.
Okay. So now we can just draw the equivalent circuit. This is E equivalent, this is R equivalent, and this is the current flowing here, and here is the current. So for this circuit, we can write the equation of terminal potential difference for this cell. The terminal potential difference for the cell is V is equal to E minus IR, because this is
Yes,
in
sir.
the discharging condition. So here you can write V is equal to, instead of E you will just replace it by E equivalent minus I into small r equivalent. Here will be small r. Small r here you will take. So now this is our equation. This is our equation. And what is the value of E equivalent? This is 3E.
3. Yes, sir.
And this is I. What is this RE? 3R.
3R.
Yeah, 3R. So this is our main equation now. This is our main equation. So what you will do here in this graph, you can see at this point, if you are at this point, the current is 0. If the current is 0,
Yes, sir.
what is the potential difference V? For current 0, potential difference is 6 volt.
Yes, sir.
When you will put I is equal to 0, you will get V is equal to 6 volt. Now put this in this equation 1. Put this
Yes.
value in this equation. Then instead of V, you will put 6. This
Sir, it
will
will
remain,
be 2.
yeah, this will be I is just 0, and this
Yeah,
is
so it will
3
multiply to
yeah.
0.
So E you will get 2 volt.
2, sir. Yes, sir. 2
Yeah,
volts.
E you will get 2 volt. Now see in the graph now, when the current is 1 ampere, the volt potential difference is 0 here.
Yes, sir.
Yeah. When current is 1 ampere, potential difference is 0. So just put all the value in this equation. So V is equal to 0 now, and this will remain as 3E minus current this time is 1 ampere, and this is 3R. So From here you can find the value of internal resistance. 3 is equal to 3R. This 3 and 3 will get cancelled out. R is equal to E. And what is the value of E? E is 2 volt. So
Is 2
E is
volts.
2, not the volt. So R is equal to 2 ohm. 2 ohm we will get. R is
Yes,
equal
sir.
to 2
2
ohm.
ohm.
R is equal to E means the value of R is equal to E. Value of E. Not the unit. Unit will be different. Okay. So we have got this, and what they are asking what is the EMF and internal resistance of each cell. So EMF of each cell we have considered E. So the EMF of each cell is 2 volt and internal resistance of each cell is 2 ohm. So you can write here
2 ohm.
EMF and internal resistance of each cell is 2 volt and 2 ohm respectively. Harsh, can you take the screenshot of all?
Yes, sir. Yes, I will.
Okay, you can take the screenshot because it will save our time.
Yes, sir.
Just take the screenshot. And you can arrange it now
Yes,
properly.
sir. Yes, sir. Can I scroll down, sir?
Yeah. Take this.
Yes, sir. Can I scroll down?
Yeah. Okay, now
Yes,
this.
sir.
Done?
Yeah, done, sir. Second question, sir.
Okay.
Yes, sir. Can I scroll down?
Yeah.
So that's
Okay.
it, sir. Third question.
Very, very good.
Sir. Can I scroll down?
Yeah.
Yes, sir. You can scroll down.
Yeah.
Sir, can I scroll down?
Okay. Oh, fine.
Sir, done, sir.
Okay. And what you will do at your home, you
Okay.
will see these questions once again. Okay, because
Yes,
these
sir.
questions are very good question, and you can skip this question. You
The
can
second
skip
one.
this question. This question you can skip because this is not the part of your syllabus now. And now the topic is Kirchoff's laws. And
Yes, sir.
so why we are studying the Kirchoff's laws? Because we have there are many types of circuits we have. We have a series combination of cells, series combination of capacitors, resistors, parallel combination of cells, capacitors, and resistors, and we have sometimes the mixed combination. Means we have a circuit. We have studied the circuit till now that we can identify which type of combination is this, series or parallel combination. But there are some types of complex circuits in which we cannot identify whether the resistances are connected in series combination or the parallel combination.
Yes, sir.
We cannot identify there. So for solving that kind of circuit, what is the meaning of solving? Means for calculating the equivalent resistance, for calculating the terminal voltage, for calculating the current. Okay, we have to use these Kirchoff's laws. Okay,
Yes, sir.
so that is why we are studying the Kirchoff's laws. Okay.
Yes, sir.
Okay. So Kirchoff is the name of scientist. He has given two laws. Okay, he has given two laws. So the first law he has given based on the conservation of charge. Based on the conservation of
Conservation of charge.
means conservation of charge means uh, we know that charge is conserved. Suppose charge is flowing through a conductor. Charge is flowing through. Suppose this is the conductor. Suppose this is the conductor you have, and the charge is flowing from here to here. From here to here, the charge is flowing. So
Yes, sir.
you can see here the amount of charge the amount of charge here, the amount of charge here, or the amount of charge here will remain same, because charge will be conserved, charge will never change. If 2 coulomb charge is here, then again the 2 coulomb charge is here, again the 2 coulomb charge is here. Charge is nothing but the amount of electron, or the amount of the ions, or you can say ions, that is flowing, that is the quantity, and that will never change. Okay,
Yes.
so the first law is based on the conservation of charge. Okay, so okay, fine. So for the first law, this law is also known as Kirchoff's current law. Kirchoff's current law. So, so this law is the current law, I will say, current law. And this is also known as the junction law. Junction law. And in short form, sometimes we say it as KCL, Kirchhoff's current law. Okay, in short form, we say Kirchhoff's current law. So, what this law is, suppose you are having these 3 wires, like this, and this is the junction point. What is the meaning of junction point?
Where two
Junction point is the
electromoles
point.
meet.
Yeah, junction point is the point where all the wires are meeting.
Yes,
Where
sir.
all the wires are meeting. Suppose I1 current is coming like this, and I2 current is coming like this, and I3 current is going like this. So just you are standing here at the junction. You are here at the junction now. Okay. You are at the junction, and you are watching some current is coming towards you from this wire, and from this wire some current is coming to you. And when you are watching this wire, you will say that some current is going away from you. Okay, so according to this law says that so first I will write this. This is first I will write this. What is this law? According to this law, according to this law, the sum of all currents, or you can say algebraic sum, according to this law, the algebraic sum of all currents at the junction is zero, and you have to take the current with sign convention. For the sign convention, number one, if the current is coming towards the junction,
Yes, sir.
if the current is entering the junction, then you will take that current as positive.
Yes, sir.
Current entering the junction is positive. Current leaving the junction is negative. The meaning of this, na, is same as this. Okay, this here I have written junction. This means junction. Okay. Do you know about this? This two commas means here I have written
Yes, sir. Current and
current.
current,
Here
the junction is the same word.
we,
That's why I put comma.
yeah, we do this for saving our time. So
Yes, sir.
now you are here, and if you want to find, now I am taking this wire again. Taking this wire again, na? And whenever you want to find the equation of current, what you will do? So you will assume yourself at the junction. You will assume yourself at the junction, and from there you will decide the sign of current. So now, what is the sign of this current I1? Means according to this law, the current at the junction is 0, but you have to take the current with sign. So this current is entering the junction. If you are here, suppose this current is entering the junction, when you will see from here. So this current entering current, you will take current entering, you will take positive. So you will take this plus I1.
Yes, sir.
And for this you will take plus I2. And what you will take for this, because this is leaving, you will take negative. So here you will write minus I3, and this is the algebraic sum of current at the junction, and this is equal to 0.
0.
So what is the value? I1 plus I2 minus I3
3 is
is
equal to 0, 0.
0. So this is the thing you have to remember.
Yes, sir.
Means entering current, and how you will identify whether the current is entering. So you will suppose that
The arrow, sir.
yeah, you will suppose that here you are here, and you will see the direction of it. Okay, now
Yes,
we will
sir.
solve one question on it. Very easy question.
Yes, sir.
From here, 2 ampere current is coming like this, and this point is O point is the junction point, and 3 ampere is like this, and 1 ampere is like this, and we don't know what is the current in this wire, what is the magnitude of the current in this wire, and what is the direction of the current in this wire. So we have to find current in this wire. Okay, so this is a question that we have to solve. So how we will solve? We will apply here KCL. When we will apply KCL, now it's okay, Harsh? It's okay now? Now you are getting my voice?
Yes, sir. Yes, sir. Sorry, sir. I got disconnected.
Okay, no problem. So we have this question,
Yes, sir.
and we will solve this question. We will apply here Kirchoff's current law. What is Kirchoff's current law? Summation of all the current at the junction is equal to 0.
0. Yes, sir.
Summation of all the current at the junction is equal to 0. So now, what is the what you will take? This 2 ampere positive
Sir,
or negative?
+2, sir. +2, sir.
Very good, very good. Plus 2 and
+2 and then +3 and then -1.
plus 3, then -1 and plus
Yes.
I.
Yes, sir.
And you
Physical
will not
number.
take any sign of this I, because you
Yeah, sir,
don't know
because
whether the
where
current
it is
is
going.
leaving.
Yes, sir.
So now we will find from here the value of current. We will get as
It will be
-4.
-4, sir.
-4 ampere. So
Yes,
-4 means the current is leaving or current is entering.
leaving, sir. Leaving.
Leaving means current will be like this,
Yes.
and the value of current will be 4 ampere. So this is the current KCL, Kirchoff's current law, and this type of question you can get from this law. Very, very easy.
Yes.
So
Sir.
just note it down, and after that we will discuss the most important KVL, Kirchoff's voltage law.
Voltage.
That we will use in solving the numerical. And I am adding one more point. Just wait. I am adding one more point here. You can add one more point. Kirchoff's current law is based on conservation of charge. What is current? Current is simply the charge in the motion. Current is simply the charge in the motion, means you can say charge is coming from here and charge is coming from here, and all the
Yes.
charge meet at this point, means here
Yes.
is this charge 3, charge 1 is coming, charge 2. You can think like this. Some water is coming from this here, from
Yes,
through
sir.
this pipe, and some water, this wire, suppose wire as a pipe, and current or charge as water. So suppose some water is coming from here and some water is coming from here. So you will get the addition of two water equal to this. So means this is the conservation of charge. Okay. So just note it down.
So guys, hold on. So guys, hold on. Done, sir.
Okay, very good. Next, we will have the Kirchhoff's voltage law. Kirchhoff's voltage law we will have. Second, we will have Kirchhoff's voltage law, and in short we say KVL. KVL, or sometimes this is also known as loop rule. So okay, so what is this now? And this Kirchhoff's voltage law is energy, means what happens? We have cells. Harsh, I think your internet connection is not okay.
Sir, just me. Sir, I'll read him just.
Okay. So now it's okay.
I think it should be okay.
Okay.
Sir, it's like this for 1 week. Sir.
What?
The internet connection. Sir. It's not good.
Just wait. Check your speed.
No, sir, like my laptop is hanging. Sir.
Okay. So you can restart. You can restart that, and you can
I
join it
think,
that again.
sir, you can continue if I'll
Okay.
know.
Okay.
I'll let you know, sir, if I'll have to finish.
Okay. Fine. If there will be a problem, then you can let me know, and you can start your system. Okay. So so what is this Kirchoff's voltage law? So this law comes from the conservation of energy. Conservation of energy means we in the circuit we have the cells, we have resistances. So uh, what happens, the cell is the source of energy, means cells provides the energy. When cells are in the working condition, they provides the energy, and the resistances, and that energy is expanded across the resistances, means the energy provided by the cell is expanded across the resistance or load, means the energy remains conserved. Okay, the energy remains conserved. So according to this law, first you can write this is based on Harsh. Every is all things okay? Are you getting my voice and all that?
Yes, sir, I'm getting your voice, but in between, your voice is lagging, sir.
Okay, because your internet connection is not
Yeah, it's my internet connection, sir.
okay.
Sir, you can continue, sir. I'll let you know if there is a problem.
Okay, fine. Because today's lecture is very very important. You know that.
Yeah,
Uh,
yes, sir.
this Kirchhoff's voltage law is very very important. If you are getting problem, then you can restart. No problem. We will continue. And
No, sir, you can continue, sir. I'll
okay,
let
fine.
you know if there is a major problem.
Okay. So this is based on the conservation of energy. Conservation of energy. So you can say the energy provided by the battery or the cell the energy provided by the battery or cell is equal to the energy gained by the resistor. Resistors in the network.
Yes, sir.
So what is this law now? according to this law, algebraic sum of all voltages in a closed loop of circuit is 0. Closed loop of circuit is 0. Just wait for a minute, you will understand each and everything. Okay?
Yes, sir. Yes.
Just wait. When we will apply this, right now I think you will not get this. Means when we will
No, sir.
apply this,
Yeah,
then
yeah,
you
yeah.
will get this.
Sir, actually, I've done this. So yeah, it's
Okay. So in this, the sign convention is very important. Sign convention.
yes, yes,
Okay.
sir.
So sign convention. So just write rise in potential. You will take as positive, fall in potential you will take as negative. Now I will give you the time for making notes. Okay. So for example, suppose you have a cell this or battery this, and suppose this is the terminal at higher voltage, this is the terminal at lower voltage. This is the terminal at higher voltage, not voltage, this will be potential, because voltage is the difference of potential. This will higher potential, lower potential. So suppose if you are moving from here to here, if you are moving from here to here, if you are moving like this in this direction in a circuit, if you are moving in this direction, so you are moving from higher potential to lower potential, you are moving from higher potential to lower potential. So the potential is decreasing or potential is increasing? Means, is there a rise in potential or fall in potential? There is a fall in potential now. You are just moving from higher potential to lower potential. Okay. So means there is a fall in potential.
Yes, sir.
So if there is a fall in potential, then if suppose this is the EMF of this cell, or then you will take this E as negative. Okay. One by one, step by step, you will understand all the things. Okay. So now let's see this. I am taking one more example. Suppose if you are moving in this direction, means you are moving from now in a circuit, you are moving from here to here. So you are moving from lower to higher potential, means the potential is increasing. There is a rise in potential, so you will take this E as positive this time. When we will apply this in a loop or in a circuit, then we will get the better understanding. Okay, fine. Now there can be the chances that you will get this type of thing. Means here is a resistor connected and current is flowing in this direction. The direction of current is in this direction, and you are moving in this direction. You are moving in this direction. And can you tell me what is the potential difference across this resistance? What is the potential difference V across this resistance? V is equal to IR, na?
Yes, sir.
V is equal to IR. So what you will do if you are moving from here to here in this, if you are moving from in this direction, and we know that current always flows from higher potential to
Potential
lower
to lower
potential.
potential. Yes, sir.
Current flows from higher potential. Just a minute. Okay, Harsh. So we already know that. I am not telling any rocket science. Okay, this is very basic and simple thing. Just
Yes,
listen.
sir. Yes, sir. Of course.
Here the current, we already know that the current flows from higher potential to lower potential. So if we are moving in this direction, means we are moving from higher potential to lower potential, means the
Yes,
potential
sir.
is decreasing, means the
Yes, sir.
potential is decreasing, then this V is equal to IR you will take as negative. You will take V is equal to IR as negative.
Negative.
Okay, fine. There can be the chances that you can get this kind of thing also. Now, uh, now in a circuit, if you are moving from, are you getting the cursor now?
Yes, sir. Yes, sir.
Okay, that's fine. Now you have a wire, this or this is the part of the circuit I have taken, and now you are moving from here to here. Means in the opposite direction of current you are moving. You are moving in the opposite direction of current,
Yes,
and
sir.
when you are moving in the opposite direction of current, means you are moving from lower potential to higher potential.
Higher
Means the
potential.
potential is increasing, so you will take this potential difference
Plus,
across this
sir.
resistance as plus IR. Now all things are clear. Now it's time to apply this thing. It's time to apply this thing. Now I am taking just one. I am taking just one circuit, and we will apply there. How we will apply the Kirchoff's voltage rule or Kirchoff's voltage law.
Yes, sir.
The application
Yes, sir.
part is very important. Okay, the application part is very important, because finally you have to apply this on the questions. This is not as important, the sign convention and all that. You should know how to apply this KVL. So now let's
Yes,
see.
sir. Yes, sir.
I am taking one example. I am taking one example. Suppose we have a circuit like this. Here one cell is connected like this, and okay, and this is suppose R1 and this is R2. And this is the direction of current. This is the direction of current here. Current is flowing like this, like this, like this, and like this, and like the current is flowing like this. Okay, fine. So now, uh, this is the circuit we have. This is point A, this is point B, this is point C, and this is point D. So you can choose any path. You can choose any path. You can choose path A B C D. You can choose path D A B C. You can choose path B C D A. Means you can choose a path in a loop. Loop means a close a closed path. Okay, this is the closed path now. Okay, just fine. Harsh, are you getting me?
Yes, sir. Yes, sir.
Okay, just now see this, how I will apply this. Okay, now I want to apply Kirchoff's voltage law in this circuit, and this law is valid for closed loop, so this is a closed loop. Okay, just see now. Suppose I am moving like from A, B, C, D. I am moving from A
Yes.
to D. I am
Yes, sir.
moving from, I am
A
choosing
to
a
D.
path. I am choosing a path A, B, C, D, A. So when I am moving from A to B,
Yes,
and
sir.
when I am moving from A to B, so you can see here, here this is at the higher potential,
Yes, sir.
this is at the higher potential, this is at the lower potential. Okay, so when you will see this cell,
Yes,
there
sir.
is only cell, there is only cell here, no resistances, no
Yes, sir. No,
resistance is
no
there.
resistances.
So we are moving from, and this have the EMF E1, this have the EMF E2. So
E2.
you are moving from higher to lower potential.
Yes, sir.
Higher to lower potential means the
Sign will be
potential
minus.
is, sign is minus. This E1 we will take with minus sign.
Yes, sir.
Now come here. A to B. Now B to C. In B to C there is a resistance,
Resistor.
and see here the direction of current. We will see the direction of current when we are crossing the resistance. When we are
Yes, sir.
crossing the resistance, then we will see the direction of current. Now see the direction of current here. The current is flowing like this, means from higher potential to lower potential.
Lower potential.
So what you will take? What you will take? The
Minus
value of minus I into
I.
R1,
Yes, sir.
because V is equal to IR. With
Yes, sir.
potential difference across this will be IR, and you will take negative because you are moving from
Higher to lower.
higher potential lower. And now you can see here this.
It was a minus A2, right?
No, it is plus.
So it is
It is
higher to
plus.
lower.
Huh.
Oh,
It is
yeah.
we are moving from higher to lower. Okay, sorry. This will also minus sign. This E2 will also be minus, because we are moving from higher to lower. Okay, you are
Yes,
right.
sir.
This is E2. Okay,
Minus
now
A2.
A, B, C, D and D to E.
Plus
Again, you
IR2.
will take this minus IR2.
So plus, right? Lower to higher.
No, because you are moving in the direction of current.
Oh, yeah.
Whenever you are moving in the direction of current, and resistance in between, always take minus IR, because
Okay.
you are, why you will take minus, because you are moving in the direction of decreasing potential, because current
Yes, sir.
is in the current is flowing, current always flows in the direction of in decreasing potential. So, and
Yes, sir.
this all equal to zero, this all equal to zero. Now
0.
suppose so just take the common, this will become E1 plus E2 plus IR1 plus IR2 is equal to 0. Okay, this is the equation we have. Now we will change our path. We will change our path, and we will see, will the answer remain same or will the answer will change. Now I am choosing a path.
From D to A.
I am choosing a path ADCBA. ADCBA in the opposite direction of current we are moving.
Okay.
ADCBA.
CBA.
Now you are moving in this direction, means now you are
Yes.
moving like
In
this.
the opposite direction of the current.
Current. So what you will take? Plus IR2.
Yes, sir, because in opposite direction.
Yeah.
Yes, sir. Plus
Plus
IR2.
IR2. Okay. Now here you
Plus
are
E2.
moving from plus E2. Very good.
Yeah, but high, lower to higher.
Yeah. Okay. Now here, what is the? You are moving in the opposite direction of current.
Yes,
In this
sir.
direction you are moving. So here also you
So
will
plus
take.
IR1.
Now
And then
from here lower to higher you will take plus
plus
E1.
E1.
So means answer will remain same.
Yes, sir.
So here you will get the answer E1 plus E2 plus IR1 plus IR2. So no matter which path you are choosing, your answer will always remain
same.
So okay, just note it down, and we will have very good question after this.
Yes, yes, sir. So can you scroll down sign convention?
Yeah. And be prepared because the questions based on the KBL, it is a little bit lengthy. Okay, is little bit
Yes, sir.
lengthy because we have to form equations and we have to solve the variables. So that is why question looks lengthy. But
Yes, sir.
questions are easy, no problem. We can solve it. But the calculation is uh, there is a there is calculation in the question. Scroll down.
Yes, sir. Can you scroll down?
Scroll down.
Yes, sir. Yes, sir.
So you can choose any path depending upon you, and you will get the same answer.
Yes, sir.
Completed, Harsh?
So just a minute.
Okay. The direction you are taking, the sign you are taking is very, very important in KVL. Because all things are depending upon what type
Yes,
of sign you are taking.
yes, sir.
The equation will form on the basis of sign you will take, and accordingly you will get the answer.
Done, sir.
Okay, fine. Now we will have one question. This question we will have, and we will see why we will apply here KVL or KBL. Why we will apply here. Okay, and here is a resistance of 5 ohm. Just first note this down, and after that we will solve it. Okay.
Yes.
Yeah. This P dot D means potential difference.
Yes, sir. Yes, sir. Done, sir.
Fine. So okay. This circuit is given. So we cannot find whether this combination is series combination, whether this combination is parallel combination. We cannot find it. Okay. We can only find that these two resistances are in series, but overall we cannot say that this whole combination is series or parallel. We can solve it with the concept of series and parallel combination. So we have to apply here. You can see, you can check if you find that this is a series or parallel. We cannot find now here. So we will apply here KVL. So they are asking, this circuit is given. Has completed the question.
Yes, sir.
Okay, now it's okay, na? Means voice and all that.
Yes, sir. It is okay till now.
So why we are applying KCL here, KVL here? Because we don't know which type of combination is this. Okay, and Kirchoff's voltage law is valid in each and every circuit. Okay.
Yes, sir.
So they are asking, find the current through each resistor, voltage across each resistor,
Power
potential
dissipated.
forward dissipated potential, and all that. Means first we have to find the current.
Yes, sir.
So for solving this type of question, what you should do? I am supposing this point as A, this point as B, this point as C, this point as D, this point as E, this point as F.
Yes, sir.
So for the first step, what you will do? Step 1. For the step 1, you will choose the division of current. Means you will choose the current division in the circuit.
Yes, sir.
You have to assume the current first and you have to divide that current in the circuit. So I am supposing that this is the higher potential at higher and this is at lower, and so current is flowing like this. Suppose I1 current is flowing from here. I am
Yes, sir.
supposing, you can suppose I2, and I am supposing I1. I1 current is flowing like this, and you can see this wire, this wire, this wire, this wire is same. Means here
Yes,
also
sir.
the I1 current will flow.
Yes, sir.
Okay, but when you will come at this point,
It will be I2.
come at this point, here is this is the junction point. Means the current will go, some current, some I1, some part of I1 will go in this direction, some
Yes.
part of I1 will go in this direction. Here is also I1. Suppose in this direction the current is going is I2, because why the current is changing? Because this,
There
here
is
is the
junction, sir.
branching,
Yes, sir.
due to the branching the wire change and the current change. So what is the value of current here in this direction?
I2.
From
No.
I1.
Okay.
From I1, I2 current goes in this direction. You
Yes,
can
sir.
apply here the junction rule, na? You can apply here the
Yes,
junction
sir.
rule. When you will apply here the junction rule, you will get the current I1 minus I2.
I2 is equal to 0.
No,
Yeah,
because
okay.
you can say I am just applying the junction rule, means current rule at here at this junction.
Yes, sir.
Here I1 is coming like this,
Yeah. Plus 7 minus I2.
I2 is going like this, and we don't know what is the current here. So
Yes,
apply
sir.
the junction rule. I1
Plus
is
I1.
positive,
Yes, plus I1
I1
minus I2.
plus I1, and
Minus
here this is coming. You are at the junction, and this is coming towards the junction. You will take I1 as positive,
yes, sir.
and you will
I will
take
take
this
negative, sir. Minus
I
I2.
as negative, and this I2 as negative, equal to 0.
0.
And you will get I is equal to I1 minus I2. This is you have applied at the junction D. Okay.
Yes, sir.
No need to apply this, because you know that if you have a I1 current here and I2 goes here, if you have a I1 current here and I2 goes here, then I1 minus I2 current will go in this wire. Okay.
Yes, sir.
So here also the current is same. Here also the current is same. Means here
I1
also the
minus
current
I2.
is I1 minus I2. And here also the current will same in this
Yes, sir.
direction. Current is I1 minus I2. In this resistance, the current is I1 minus I2. And here also the current is I2. And here what is the current? I1 minus I2.
I2.
Okay. Okay, fine. Now you can see that here I2 and I1 minus I2 is meeting
Yes, sir.
at this junction. So from here, when you will apply the junction law, you will get the current I1 again.
Yes, sir.
You will get the current
I1.
I1 again. Okay, now we have just defined the current, or we have taken the direction of current. Okay. Now we will choose the number of loops we have.
Yes, sir.
One loop is this,
We have 2 loops, sir.
second loop is this, and we have actually 3 loops. Okay.
Oh, yeah, the third whole circuit.
So see this. Step second. Actually, we have I1 and I2. We have to find I1 and I2. Means we have 2 variables. To find, that is I1 and I2. So we will choose two loops. So number of variable will tell us how many loops we have to choose. Means on how many loops we will apply the KVL. Okay. Okay. The third step, I have taken this loop first, and then I will take this loop. Okay. So third step is, so I will move in this loop like this, and
Yes,
in this loop I will move like this. In one loop I will move in the direction of current. In second loop I will move
opposite
in the
direction.
opposite direction. And it will depend totally upon you. You can choose any of the path. I am choosing this path. Okay. So step third is now apply KVL on loops. So now we will apply the KVL on loops.
Yes, sir.
So now I am just choosing this loop A D C B A. A D C B A. Okay. A D C B A. So we can do this now. We can
Yes,
solve
sir.
for AD. You will write, you are moving in the direction of current.
Yes, sir.
AD. So you will write minus I1 into 10.
Yes, sir.
So means you will write minus 10 I1.
Minus 10 I1.
Now you are moving from D to C. Now you will write minus 5
Minus,
I2.
yeah. Minus 5
Minus
I2.
5 I2. Now you are moving from here to here. There is no resistance. But now you are moving from here to here. So what you will write? Minus
Minus,
minus
I1.
I1. Minus
I1.
I1.
Yeah. I1.
Minus I1. And what you will write, because you are moving from lower to higher, so you will write plus 2.
Plus 2.
Yeah. You will write this as plus 2. Now this minus 10 I1 and minus I1, this will become minus 11 I1.
Minus 11 I1.
And this will become minus 5
Minus
I2
5 I2 plus 2
plus
is equal to 0.
When you will take minus common, you will have this. This is our equation 1. And
Yes,
we know
sir.
that we have two variables I1 and I2. We have to make two equations. One thing always remember, if you want to find the values of two variables, then at least you have two equations.
Yes, sir.
If you want to find the values of three variables, you should have at least three equations. So now I will choose this loop D C F E D. Okay.
Yes, sir.
Now I will choose the path D C F E D. F E D. So D C F E D. D C F E and D. So what you will write for this? Minus 5 I2.
Minus.
Because
So it
you
should be
are
plus, right? Yeah, it's
no,
minus. It's in the direction, right? I'm sorry.
we are moving in the direction of current.
Yes, sir.
Okay.
Minus.
So it means we are moving from higher potential to lower potential.
Lower potential.
So we will take minus 5
minus
I2.
I5.
So minus 5
I2.
Okay. Now C to D. Now from C to D, we are moving in the opposite direction of current. Current is in this direction and we
Yes,
are moving
sir.
in this direction. So
Yes,
what
sir.
we will
Plus,
write?
Plus 5 I2.
Plus 5 I1 minus I2.
I1 minus I2. Yes, sir. Sorry.
Plus 5
I1
minus I2. Okay. Now we are moving again in the opposite direction of current. So here also
Yes,
we
sir.
will take plus 2 I1 minus
I1
I2.
minus I2.
I1 minus
I2.
Now from here, this is the higher terminal, this is the lower terminal, means this terminal
Minus 5,
has
sir.
the minus 5. Very good. Higher to lower, you will write minus 5. And this will equal to 0.
Yes, sir.
So now when you will solve this, this will become minus 5 I2. This is 5 I1
5
minus
I1
I2
minus 5 I2.
plus
Yes,
2 I1 minus I2. This will become 7 I1
I1
minus
minus
I2 minus 5 equal to 0. This is 5 I2. This will become 7 I1 minus 7
I2
minus 5 equal to 0.
It will
Now
become minus
this will
12.
become 7 I1 minus 12 I2.
Yes, sir.
12 I2
Minus
minus
5
5
is
equal
equal
to
to
0. So this is your equation 2. Now you have to solve equation number 1 and equation number 2 for getting the value of
Yes,
current.
sir.
When you will solve this equation, and you will solve this equation. You will get the value of current. And how you will solve this? Just I am writing here, solve equation 1 and 2. For solving these types of equation, we will use elimination method in 10th class. I think we have
Yes, sir.
done.
Yes, sir.
So what we will do?
Subtract.
No, by subtraction we will subtract it, but first we will multiply something.
Yes, yes, sir.
Multiply whole equation this with 7 and multiply this whole equation with 11. Why I am doing this? Because I want to cancel this two terms.
Yes, yes, sir.
I am multiplying this 7 in this equation, this 11 in this equation.
That
Okay.
yes.
So what we will get here? We will get now for this
77.
equation we will get 77.
77 I1.
I1 here we will get
35 I2 minus 14
equal to
0.
And for the second equation I can write
77
I1 minus 12 into 11. 12 into 11, can you multiply it? Well, you will get 132.
130, right? 132.
2 you will get.
Yes, sir,
I2
and then
I2
minus 55
minus 55 equal
is
to
equal to 0.
Now you will subtract both the equations.
Yes,
Subtract this and this
yes.
will become plus, this will become again plus. So this will be cancel out. So
Yes,
here
sir.
you will get when you will add this and this
Cancel
will
out.
get cancel out. Okay. So this is cancelling out. So now you will add this and this. Okay, because you
Yes,
are
sir.
subtracting. This is 35 minus and minus 132 minus plus. So this will become
Yes, sir.
35 plus 132. You will get 167. 167 I2 you will get. Okay.
Yes, sir.
And here you will get here is minus 14 plus 55. You will get 41.
41.
Minus plus 41 you will get. Here you will get plus 41 and that is equal to 0. So what is the value of I2? I2 is minus 41 by 167, and when you will solve this you will get I2 is 0.24 minus 0.24 ampere is the I2.
Yes, sir.
Now we have find it out the I2. Now we will find I1.
We'll put in one equation the value of
Put
value of I2 in equation 1.
0.24 in any of the equation in equation 1. So what is the equation 1 we have? This is the equation 1 we have.
11 I1.
So 11 I1 plus 5 I2 we have minus 0.24 minus 2 equal to 0. When you will solve, you will get the value of I1 as 0.29 ampere. Okay. And one thing I want to tell you, this negative sign, what is the meaning of this negative sign? This meaning of negative sign is that I2 you have chosen I2. Where is I2? This I2 means
yes, sir.
you are taking I2 in this direction, but this I2 comes out to be negative. It means that this I2 is in this direction.
Yeah,
I2
direction.
in the opposite direction.
Opposite direction.
Yeah, the meaning of the negative sign. So I am writing here. Negative sign shows that the actual direction of current is opposite to the direction of current we have supposed. Means we have supposed that the I2 is flowing in this direction, but the I2 is flowing in this direction
Yes, sir.
because I2 is negative. So I1 and I2 we have find it out. Now this
Yes,
means
sir.
you have just completed the 85%. You have solved the 85% of the question. Now 15%
Yes, sir.
finding I1 and I2 in this question means 85% of the question you have solved. Okay. And one thing I
Yes, sir.
want to find, one thing also I want to find I1 minus I2. When you will find I1 minus I2, you will get this is 0.29 minus and this
Minus
is minus
0.24.
4 and you will get 0.53
0.5.
ampere. So I1 minus I2 is equal to 0.53 ampere. So please remember all the values of current you have. You have now this
Yes,
I1,
yes, sir.
this I1 you have, and this I2 you have. Okay. You have I1, you have I2, you have I1 minus I2. All the currents we have now. So what is the first question? Just see the first question.
Current
There are
through each resistor.
each resistor. Current through each resistor means current through this 1 ohm resistor, current through this 10 ohm resistor, current through this 5 ohm resistor, current through this 2 ohm resistor, current through this 5 ohm resistor. So we can find it now very easily. So see the circuit.
Yes, sir.
Okay. Now we can find all the currents here.
Yes, sir.
Okay. Now what is the current across number one? Now answer first. Answer first. Current. What is the current across this 1 ohm resistance?
It's I1, right?
Yeah. Current across 1 ohm. What is the current across 1 ohm is I1.
I1.
What is the
Yes,
value
sir.
of I1? I1 is
Yeah.
0.29 ampere.
0.29.
Okay. And now current across 10 ohm resistance.
It's I1.
Yeah. Current across 10 ohm resistance. This is again I1
Yes, sir.
and this is again 0.29
29.
ampere. Now, if you want to find the current across this 5 ohm resistance,
It's I2.
yeah, current across 5 ohm resistance, 5 ohm between, because we have two 5 ohm, this 5 ohm and this 5 ohm. We are talking
Yes, sir.
about the resistance which is in between point D and C, between
Yes,
point
sir. D and C.
D and C. What is the value? I2.
I2.
I2 is minus 0.24 ampere.
29. Yeah, 24.
24 or 29?
24, 24, sir. 24, sir.
I2 is 24 ampere. Now which one is remaining? This 5 ohm.
I1 minus I2.
I1 minus I2. But 5 ohm, this 5 ohm is between C and F. This 5 ohm is between C and F.
Yes, sir.
This 5 ohm I am talking about. This is between C and F.
C and
5
F.
ohm
Yes, sir.
between C and F. What is the value? I1 minus I2.
I1 minus I2.
So what is I1 minus I2 is 0.53.
Yes, sir.
0.53 ampere we have already calculated.
Yes, sir.
0.53 ampere. So last remaining means across 2
It
ohm
is the same as
resistance.
0.53 ampere.
Yeah,
It's I1 minus I2.
across current across 2 ohm. So what is this? I1 minus I2, that is again 0.53 ampere. Okay. So current
Yes, sir.
part is over. Current part is over.
Yes, sir.
Now we have to find the
Voltage across
voltage.
each resistor.
So we can find the voltage also.
V is equal to IR.
Yeah, we already know the voltage.
Yes,
Equal
yes.
to V is equal to IR, means we know I, we know R.
R.
So
So we'll just multiply it.
yeah,
So it is a very big question.
I was saying now. So answer second. Uh, Voltage across
Each
1 ohm.
resistor. Yeah. So it will be 0.29 into.
What I am going to do now? I'm just copying this. Instead of current, I will write voltage.
Yes, sir.
But you have to write all the things.
So should I just take the screenshot?
Of course, you can take the screenshot when we will complete the question.
Yes, sir. Then I'll write it afterwards.
Yeah. I'm saving the time actually, but I don't know. I will be okay. Is it fine now? Okay, fine. So sorry. Yeah. So now this is the second part now.
Yes, sir.
Second part means we have to find the voltage. So instead of current, I will write only voltage. Voltage across so now we have to find the voltage across 1 ohm. So what we will do? We will just write
Multiply it, right?
multiply it. Uh, Voltage across 1 ohm is equal to what is I1 means
0.29.
I1 into 1.
Yes, sir.
I1 into 1 we will
Yes,
write,
sir.
and this will become
29.
0.29 volt.
Yes, sir.
Now voltage
Across.
10 ohm. So what you will do?
I1 into 10.
Means I1 into 10.
Yeah, 2.9.
So this will become 0.29 into 10. This will become 2.9 volt. So voltage across 5 ohm. So what you will do? This is V is equal to IR. V is equal to what is I this time?
Minus 0.24.
Okay. Minus. You can take the magnitude only. 0.24. And what is the resistance? 5 ohm.
Yes, sir. 5 ohm.
So this will become 11.
Yes.
No.
No, not 11. We just
1.1. 1.1 volt.
1.1.
This is simple calculation you can do by yourself.
Sir.
Voltage across 5 ohm. So means here also
0.53 into 5.
Yeah, means 0.53 into 5. You can calculate it. So voltage across 2 ohm.
0.53 into 2.
This will become V is equal to 0.53 into 2.
Yes,
So we have solved 2 parts of the question, means 3 parts are still remaining, and
yes, sir.
So just we can solve it.
Power distributed across 5 volt resistors.
Across 5 ohm means which 5 ohm they are asking?
This one.
Across 5 ohm, I am just saying 5 ohm between
C and F.
Yeah, C and F. 5 ohm between C and F. So can we find it? This
Yes,
is
sir.
very easy part, I will
Yes,
say.
sir.
So this is third. Power is equal to I square R.
Yes,
Power
sir.
is equal to I square R.
Yes, sir.
And what is the current across this 5 ohm?
0.53,
Means
sir.
0.53 means
Yes,
I1
sir.
minus I2 into 5.
Yes, sir.
I1 minus I2 square into 5, and this is 0.53
Whole square.
square into 5, and answer you can get. Third
Yes,
part is
sir.
completed. Now
Yes. Fourth,
fourth one.
potential difference across A and F.
Potential difference across A and F. So A and F is this.
Yes, sir.
A and F. Now we have to move A and F across A and F. Okay, answer number 4. Very lengthy question. Answer 4th. We have just finished. Okay. Okay. So A and F we have to move. So I will choose the path. Which path which I should choose? A, B,
B,
C, F.
C, F.
A, B, C, F.
C, F.
A, B, C, F. So what we should do? We should take this
Minus
figure.
I1 and then.
We should take this figure and paste here.
Yes, sir.
Okay, now A to F I am moving.
Yes, sir.
Just move from A to F and apply the KVL. So you will write first
Minus
VA.
I1.
No, you have to start from this point, na? You will
Yeah,
write the
okay.
potential of this VA,
Yes, sir.
and after that you are moving from higher to lower, means you will write minus 2.
Minus 2.
Minus 2, and you are moving in the opposite direction of current, means you will write here
Plus I1.
plus I1 into
I1, yes, sir.
plus I1 only.
Yes,
Okay,
sir.
and now you are moving from here to here, means up again you are moving in the opposite direction. So here you will write plus
I5.
I1 minus I2 into 5.
Yes.
And as the direction is opposite, you will write minus VF is equal to 0. So we have to find the potential difference between VA minus VF. So this will become 2 minus I1 plus I1 minus I2 into 5. We already know I1 is minus 0.24.
Yes, sir.
And we already know
0.
I1 minus
0.53.
I2 0.53 into 5. We can now solve it.
Yes.
Okay. Last part. Just
yes,
wait.
Sir, last part.
Potential difference between B and E. B and
Okay.
E.
Yes, sir. Again, we have to do this.
B and E. B and E. Now we will move from
Yes, sir.
B to E.
VB.
Which direction do you want to choose?
Sir, left, sir. We go left in the direction of the current.
In the direction of the current, na?
Yes,
Okay.
sir.
So just write here VB.
Yes, sir.
And minus I1.
Yes, sir.
And
plus,
minus.
No, sorry,
not,
minus, yeah. Minus. Sorry, sir.
Lower
Lower to higher. Yeah, lower to higher.
Plus. We have to take plus. Plus 2. Okay. Now,
yes,
what here we will write? Minus 10 I1.
10 I1.
10 I1. And it's all over. Minus VE.
Yes, sir.
Equal to 0. So, VB minus VE, when you will calculate, you will get I1 minus 2 plus 10 I1. You will get 11 I1 minus 2. 11 into what is I1?
0.29
minus 2. Okay. So in this way, you have to see this question is very lengthy, but in the exam, he or she can ask only 1 or 2 parts. Okay, not all the parts he will ask.
Yes, sir. Okay.
Okay. So just take the screenshot and have
Yes, sir. Can
patience.
scroll down.
taken the screenshot now?
No, sir, can you scroll down, sir?
Scroll
I will
down.
take.
Okay.
Yeah.
Oh, just I will zoom it out now.
Okay,
Will be
yes.
better.
Yeah.
Now it's fine.
Yes, I can scroll down.
Yeah. And please arrange the screenshot in a proper manner.
Yes, sir, I will.
Scroll down.
Yes, I can scroll down. A little bit more, sir. Little bit more.
Okay.
Okay.
Oh,
Yes, I can scroll down.
okay, just take this.
Yes, sir. More, sir.
More. Okay. Now it's fine.
Yes. Yes, sir. Scroll down, sir. Yes, sir. A little bit more.
Okay. Okay, no problem. We can complete. Okay, done.
Yes, sir. Yes. Yes, I can scroll down.
Done means from question number 4 by now. So one
Yes, sir.
more, na?
Last.
No, last is this, na? Last is this.
Done, sir. Done.
Okay,
I took
Harsh,
it.
done, na? So we have just completed the very big task. Means KVL is completed now. And
Yes, sir.
after this, in the next class, we will have one more question. And there is a proof of the Wheatstone bridge. Means I have told
Yes,
you
sir.
about the Wheatstone bridge R1 by R2, and that is
Yes,
equal
sir.
to R3 by R4. That we will do, and after that, this chapter, this whole thing will be finished. Okay.
Yes,
Maybe
sir.
there will be one topic, meter bridge, and now means major part is completed. 99% of this chapter is completed now.
Yes,
Okay,
sir.
Harsh. So now you can leave the class, and we will meet in the next class. And I am hoping that I know that this is very lengthy.
Yes, sir.
But
I will
but
write it. I will write.
yeah, I know that. But don't think that the examiner will ask this question in the
No,
exam,
sir. I know.
because
We'll ask one or two
otherwise
questions.
it will take 3 hours to solve all the parts, and you will only solve one question. And he or she can ask just only one part or two parts. Okay.
Yes, sir.
Okay.
So can scroll
So
down. Sir.
scroll down.
No, sir, that's it. Sorry, sir. Done.
Okay.